Hello friends. So in the last few videos we understood what is the meaning of the term set, and we began with the basic concepts of set theory. In this video we will be seeing certain kinds of sets. So the first is the empty set. So as the name suggests, any set which has no element inside is called as an empty set. So it is represented by phi, this symbol. The other way of representing it is an empty brace. That's it. So this is the empty set. The second is the singleton set. A set which contains only one element is known as singleton set. So it could be a set with the number 0 in it, only one element. This is a singleton set. In the same way, this is a singleton set. So in that any set which has only one element is known as a singleton set. The other types of sets are the finite set and the infinite set. So as the name suggests, a set with finite number of elements is known as a finite set, and a set with infinite number of elements is known as infinite set. So let us see some very simple examples. So in this we need to understand one important notation, that is the cardinality of a set. So there is a notation, for example, if we have a set A, to denote how many elements the given set has, we use the notation number of elements in A, or cardinality of the set A. This is how we write it. And this basically means how many elements does the set A have. If the set has one element, if it's a singleton set, then we say n of A, or the cardinality of A is 1. Now let us take any set. Let's say the set of natural numbers. So we saw previously that this symbol represents the set of natural numbers. It's reserved for natural numbers. So what is the cardinality of n? So as we know, there are infinite number of natural numbers starting from 1 and going up to infinity. So it's an infinite set. So n will come under the infinite set. Similarly, integers. There are infinite number of integers, from -1 till negative infinity, 0, 1 to positive infinity, integers. In the same way, the set of all rational numbers, the set of all real numbers. So these are all infinite set. Any other set, for example, all natural numbers greater than 100, so 100 to infinity, they are all infinite sets. All digits of pi can be considered as an infinite set? No, it cannot, because there are only 10 digits. So in a set, we do not repeat the digits again. So for example, if we say pi, suppose it keeps on going on. We know that pi is an irrational number with never-ending, non-terminating decimal. So even though there are infinite number of numbers on the right side of the decimal, when we make it as a set, it will only be maximum 10 elements, because 1 may be repeating many times, 7 may be repeating many times, 6 may be repeating, 5 may be repeating. So finally we only get maximum of 10 elements. So this particular set, which has the digits of the pi, is a finite set. It has only maximum of 10 elements. Okay. So can we see any other example of finite set? Let us say all the natural numbers up to 10. It's a finite set. There are only 10 elements. In the same way, so you can understand basically what I'm trying to say. A set with finite number of elements where the counting process will eventually end. So it could be 1000, it could be 10,000, but it has to end. If it is not ending, then it's an infinite set. So this is how we make the distinction between finite and infinite set. Now let's go for the other type of sets. So now we are going to see equal sets and equivalent set. So equal sets are those sets which have identical elements in them. For example, the set A has 3 elements 1, 2 and 7, and the set B also has 3 elements 7, 1 and 2. So we can say that these two sets are equal because the elements are identical even though the order is different. So in sets we don't consider the order. So here we can easily say A is equal to B. Both these sets are equal. Now when we talk about equivalent sets, we don't see what is inside the set. What we rather see is the cardinality of the set. That is how many elements the given set has. For example, let's say let's consider these two sets. So here the number of elements in A and B is same. Both are having 3 elements. So we can say that A and B are equivalent. That is, this condition says that these two sets are equivalent. They are not equal, they have the same number of elements in them. So these sets are equal and these sets are equivalent. Equal and equivalent sets, they are just for comparison, and the other sets that we saw, the empty set, the singleton set, the finite, the infinite set, these are generally the types of sets that we come across. Thank you.